Yesterday we talked about what a polynomial looks like when you zoom out. It looks like a power function, and we can usually figure out what power function it looks like. So we can figure out what it looks like way to the right, and we can figure out what's going on way to the left. But usually in algebra class, for example, when they would say graph a polynomial, they wanted all the wiggles too. Now generally, if you have a polynomial and you want to graph it, you usually need calculus. However, if you can factor the polynomial, you don't need calculus, and we can just draw a polynomial fairly quickly, and we can actually ungraph a polynomial fairly quickly. What I'd like to do is just run through some quick examples just to show you how easy it is and straightforward it is to actually graph a polynomial. The polynomials we're going to try here are all listed in the Canvas page. The first one I have is f of x equals, and I have x minus 1, x minus 3, x minus 6. Now remember, when you factor a polynomial, what you usually did with it is you set it equal to 0. And then we knew, for example, that this polynomial was 0 when x is 1, x is 3, x is 6. So right away, right, these are all over here, so I'm not going to draw much to the left, right? I know at 1, it goes through there. I know at 3, it goes through there. I know at 6, it goes through there. Now what happens with this? If I were to multiply this out, I would see that the leading term is x cubed. And I know what x cubed looks like, yes? It starts way down here, it goes like this, and then comes back up like that. So I know way over here, it's way up like this. Back to making a mess here. Yes, let's just draw a little teeny bit so I know it goes like that. And I know way down here, it goes up like that. Can you see that? There we go. Yes. So all I'm going to do is draw something. I usually like to start from right to left. It's easier. I'm going to come like this. I'm just going to come down. I know it goes through this point. Yes. I know it has to go through that point. I know it has to go through that point. Ta-da! We've successfully graphed x1 times x minus 3 times x minus 6. I don't like how flat I made it, but that's the general picture. And if someone said draw it prettier, I'm now in a position to do so. Anyways, if it's completely factored like that, we can just draw the dots, figure out what's going on way to the right, way to the left, and then just starting from right to left, draw it through. That's the first example. The second example is a little bit simpler. It's actually a lot simpler, but it's going to illustrate a point. The second example I have in the list looks like that. It's x minus 1 squared like that. Now, two things. We already know what this looks like, because this looks like y equals x squared moved 1 to the right. So let's draw it first, then we'll draw a conclusion, then we'll draw a different picture. I know this comes down like this and goes up like this. Now, even though this only has one root, this is called a double root. If a graph of a polynomial has a double root, you can see that actually near that double root, it looks like a part of a parabola. That's actually true of all double roots. And so graphing this was easy, but the one thing I want to get away from this is, is that when I have a double factor like that, it's going to look like a parabola real close to that point. The next one has just a piece of that in it. So I'm going to write down h of x equals, and then I have negative x minus 1 squared times x minus 3. Now that's completely factored. It's not a parabola, so I have to do something with it. If I set this equal to 0, like we're used to doing, I'll see that x is 1 and x is 3. So what I want to do is, I know it goes through 1. I know it goes through 3, like this. Now if I multiply this out, I will see that the highest power is a cubic, right? But it's got a negative sign out front. So instead of starting like this and snaking up, yes, it's going to start way up here like this and snake down. But meanwhile, I am going to try to live with what I said before. I know it's way down here. Now what does it have to do? It has to go through 3, and 3 is not a double root. Right? So what I'm going to do is just draw something that goes through 3 like this. Now I know it has to come down to 1, but I can't just cross right through, because if it crosses right through, in fact, let's draw that and then erase it. If it crosses right through like this, when you actually look at a piece nearby it, it looks like a line, not a parabola, and because that's a double root, it needs to look like a parabola there. So what I'm going to do is erase all this, put my 1 back here, and remember that's a double root. So this has to come down like this, hit at 1, and then go back up. You can see that still looks like a cubic, right? But we use the fact that it was a double root to actually make sure it actually just kissed to the graph right there, right? In Calc 3, by the way, the word they use is not kiss, it's osculating, but osculating means kissing, so just touching a graph like that, kissing is usually appropriate. Let's look at the next one on our list. The next one on our list, and again, is a little simpler. That's j of x equals x minus 2 cubed. Now, we know what that looks like. That looks like x cubed moved 2 to the right. So let's just go like this. X cubed moved 2 to the right. I know it's going like this. I know it goes very, very horizontal, very, very horizontal. And then it goes back up. Now, what's my point? Right? This is now a triple root. Right? So it doesn't cross straight through. Right? It goes horizontal like this. It doesn't actually go up and come back. This is a triple root. Right? And so what I'm going to say in general is if you have a triple root, it's going to look just like this. It's not going to cross straight through. It's not going to go up and come back down. It's going to go up. It's going to get very flat, and then it's going to go up just like a regular cubic would. Now let's do an example. It's awfully complicated, but it just pieces together all the things we're going to do anyway. So here we go. Now if x equals, and I have x minus 1, and I have x squared, and I have x minus 2. Oh, it's not as complicated as I thought. Good. I'm happy about that. X minus 5 cubed. Now that's a polynomial. I mean, I could actually, well, polynomials are things we factor. It's already factored. Well, normally what we did with the polynomial is we set it equal to 0 to find the roots. So we can find the roots. The furthest left one I have, I think it's just 0. So I'm just, at the moment, just going to draw this much of the graph. If I regret that later, I'll fix it. I know that 1 is supposed to be on here. I know that 2 is supposed to be on here. I see that 5 is supposed to be on here. I see that 0 is supposed to be on here. What I have here is, if I multiply this out, I have degree 1, that's 2, 3, 4. This is a degree 7 curve. I know what a degree 7 looks like when I zoom way out. Yes, it looks like a snake. It comes up like this and then goes like this. So I know that come way up here is going to start like that. And hopefully I won't have to worry about the other side. I can't quite see that. I can see the 5, but I can't see the graph. What if I see about like that? There, that'll work. Now, what do I have to do? I have to come close to 5, but it's got to look like a cubic, right? And so it's going to come down like this, and then it's got to get very, very flat, and then it's got to start going in. So if I zoom in right at that spot, all I'll see is something that looks like a cubic. I know it's also supposed to go through x equals 2. That's not a double root. That's not a triple root. So all this has to do is come bending like this, and it goes back up like that. I know that it's supposed to also go through 1, but 1 is not a double root or a triple root. It's just supposed to go through and cut through like that. So if I actually zoom in on this part of the graph, it'll look like a line. I know it's also supposed to go through 0, but 0 is a double root, right? So it needs to come down like this, it needs to go up like this, and near 0, if I were to zoom in, it would look like a piece of a parabola. That would make the double root, yes, and I get that whole graph. Right. Now you can try to do this on your calculator, but generally speaking, it's hard to get a calculator picture with all the humps actually in the right spots. You would have to actually use a different kind of scale. It's actually better if you draw these by hand than if you draw them with a calculator, which is kind of weird and kind of cool. And besides, the real skill we want is to be able to ungraph, and if we can graph them forward, we'll be able to ungraph them backwards.